Okay, so what we are seeing nowadays is there is lot of open source models which are coming day by day, and they are becoming really good despite being, low in size. So, for example, Mistral7b, the new model which came, and there was a lot of buzz around. It was 7b, which is 7 billion in parameters. Despite that, it actually performed better than many 13b models. So, for example, here is one of the benchmark where we see that the Mistral 7b Instruct actually performed better than many 13b models. For example, Wizard LM, Llama 2, Alpaca 13b, and so on. So that's where the new models are shining. So what we are going to do in this video is we are going to see some simple three use cases where we are going to see the performance of Mistral 7b Instruct model and see how does it perform. Again, these are all rudimentary codes, but definitely pragmatic. So that's what we are going to cover. So the first use case which we are going to cover is again connecting LangChain with this Mr. 7b Instruct model and see different uh, questions and their answers and see how does it perform. The second use case that we are going to cover is again RAG, which is nothing but retrieval augmented generation. So what essentially we are going to do is we are going to have a large text and we are going to split it into different portions, put it into embedding space, and then put it into store. And then what we are going to do is we are going to ask some query as question, and with RAG we are going to essentially retrieve some of those answers that we wanted to see. So the essentially what we are trying to do is the query that we have, how similar is it to the context or the embeddings that we have stored within this vector DB. And we are going to use Chroma for this. So again, everything is again built on LangChain with Chroma. So everything will be super easy. So let's see how does it perform. The third use case, what we are going to do is again using a new format called GGUF. And GGUF is nothing but a optimized format, which is essentially used for things like CPU. So you can run it on GPU also, but essentially the cases where you wanted to run it on a commodity hardware where you don't have access to GPU, you can try this GGUF format from different open source communities. So this is again what we are going to see. How does the answer performs on a GGUF model compared to models which are native in nature? So yeah, let's get started. So let us have a walkthrough of the code. So first of all, I am mounting my Google Drive at this location. Then what I'm trying to do is I'm loading all my configuration from my myconfig.json where I store normally all configurations, for example, keys for OpenAI as well as Hugging Face tokens. Then what I'm trying to do is I'm installing all the libraries which are necessary. So if you see, I have the latest version of transformers, bits and bytes. Again, for the LangChain case, we have LangChain installed. For GGF format, we have C transformers installed. For RAG, we will need Chroma DB as well as sentence transformers. So everything is installed. And if you notice, everything is running on T4. So let's see the first use case where we wanted to try with LangChain. So we will run this model with LangChain. So what I'm doing is some pretty boilerplate code where I'm just using bits and bytes configuration. So what I'm going to do is I'm going to load in 4-bit to reserve some GPU memory. So what we are trying to do is put some configuration here. Then we said that we'll be loading this model, which is again Mistral7b Instruct model. Then again, this is just for loading the model as well as tokenizer. The model we are loading in 4-bit. That's what we are going to do. Then we define a pipeline, and this is again a boilerplate code. So what we do is we define different configurations where we say that it's for used for text configuration, text generation. Then what kind of model we will use. For example, 4-bit model, and again this is already defined in the configuration here, and separate other things that we can define. Now, post that, what we are going to do is we are going to instantiate LangChain and we are going to use Hugging Face pipeline. And we are just putting a reference of pipeline that we created here. So what it is going to do is it's going to connect LangChain with this specific Hugging Face pipeline, and we are done. Now, what we are going to do is we are going to ask it some simple question. And what I have done here is I just had, one line of sentence which talks about some merger acquisition where one company acquired some another company in power sector. And we just wanted to know what was the acquisition date, which were the parties involved. So this is how I have defined the template. And if you see the Mistral7b format, how do you define as, this is something which was, peculiar to this model. So you need to define your, system instructions like this, and we can see the results. So again, this is sort of boilerplate, which you may have to, little bit modify and see how the results come. But this is again from the Mistral7b itself. Now, what I'm trying to do here is I'm just defining a question as well as context, and I'm just passing it to LangChain, and I'm asking based on this context, can you answer this? For example, from this sentence, can you say what is the date of announcement? It says the announcement was made on August 10th, which is again the right answer. Then what I'm trying to do is again with the same sentence, I'm trying to ask is which company is buyer and seller, because this is a merger and acquisition news. So I just wanted to know who is the buyer and who is the seller. And it correctly tells that, JSW New Energy is the buyer and the other company is a seller. So this is working perfectly. So let us see how does it perform with RAG. So what we have done is we have already installed Chroma DB, and with the same merger and acquisition news, what we are trying to do is we are going to use RAG for chunking this piece of news article into different document portions or different text portions. And then what we are going to do is we are going to use sentence transformers as a vectorizer and store in Chroma DB. Again, if you are new to RAG landscape, this will be little bit difficult, but essentially what we try to do is we try to chunk text into different portions. Then we put transformers or let's say some other embedding models. Like for example, we can use sentence transformers or we can use even Hugging Face embeddings to store everything into a vector database. And the vector database that we are going to use is Chroma. And the reason why we are using Chroma is because, again, it's an in-memory database, which means for very small use cases, you can put it into memory itself and see the results. So this is again, everything is a boilerplate code. So essential thing is we are passing this text, uh, chunking it and putting into Chroma DB. If you have a very large corpus, again, the methodology will remain the same. The only thing is maybe you will not be using Chroma DB. Instead of that, you might use something like, let's say, Pinecone or some other database like Elasticsearch and all. And again, in this channel, if you see, we have actually covered a lot of vector storages or vector databases from OpenSearch to, Chroma DB to others, and that's what we are going to do. So pretty simple. We are going to load this into a format called documents. We are going to split it into different text. Again, this is very rudimentary code. You can make it much more complex, but we are going to essentially split it. Then what we are going to do is we are going to vectorize it using this sentence transformers model. Again, you can change this model. You can use OpenAI's embedding models, or you can use, something as sophisticated as BI models. But again, it's a pretty simple code here. So we are going to put those text chunks into different vector stores, different vectors as such, and we are going to store it into Chroma DB. And then what we are trying to do is we are just trying to retrieve based on our query. So once we have put it into a Chroma database, what we are going to do is we are going to ask it some query, and essentially it is going to match that query with that particular vector, and it is going to return that particular vector as well as particular text which is very close to query. And query is nothing but a question. So once you ask a question, it it goes through all the vectors, see which answer is the closest, and give you the answer. So that's what this whole code is all about. And what you can do is, again, you can ask a query which is again question and see what is the result. So basically what it is going to do is the text which is retrieved from Chroma DB, it is again passed to this model, which is in our case is Mistral7b instruct, and it tries to generate the answer at the end based on the context provided from Chroma DB. So here is the same question which I asked there. So if you see earlier, it was just one or two liner, but here it's a complete news article. So what we are asking is what company is buyer and seller here? It says, JSW Energy and this energy. It's the right answer. Then again, the same question, what is the date of announcement? And we see that it says not known. So again, it failed here. But nevertheless, we can again go back and do some tweaking. For example, we can do a hybrid search rather than a dense search. So again, RAG is a pretty complex area. This was we wanted to keep it pretty simple. But yeah, there are different things which we can do. So lastly, I'm going to cover GGUF format. So GGUF format is for commodity hardware. So in the use cases where you wanted to run these large language models on CPU, you can use GGUF format. It's primarily meant for these commodity hardware or CPU rather than GPU. So here is how you are going to use it. Again, you can run it with GPU also, but the power lies with CPU. So with C transformers, you can define different configurations. For example, here what we are going to do is, the community itself has put different models for within GGUF format. So we are using this specific format. And shout out to the blog for providing this model to the community. So what we are going to do is we are just going to specify in the Hugging Face where the model is. And again, there are some different configurations. For example, there are different model files, for example, Q4K, Q4, Q2K, and so on. And you can go much more into detail, but generally this Q4K is pretty much okay enough. So it's not, neither too much big, neither too much short, and it performs pretty well. So that's what we are going to do. So rather than using, GPU, what we can do is we can install these things in a commodity hardware and see how the results come. So here, again, since it can run on GPU also, I'm just running it. And let's see the answer for the same question. So again, with LangChain, you can integrate with C transformer, so everything remains the same. You just have to change only the LLM. So this LLM, for example, earlier it was pointing to some different model as such. Again, Mistral7b, but here what it is pointing to is a GGUF model. And if you see the answers, for example, what is the date of announcement? It says, August 10. If you ask what company is buyer and seller here, it tells perfectly what are the companies, which is again JSW New Energy is the buyer and the Mitra Energy India is the seller. So that's good results. So yeah, so this was all about the three use cases which we wanted to cover with Mistral7b. At least I'm excited because again, this model is definitely performing pretty good as far as we can see, and that truly it is, open source king for smaller models like 7b, and let's see what comes into the future. Thank you everyone. Thanks for watching.